The square root property allows us to solve certain types of quadratic equations. The square root property says if b is a real number and a squared equals b, I can take the square root of both sides to solve for a. But when we do that, there are two possible solutions. A could equal the positive square root of b or the negative square root of b. To see this in a couple of examples, suppose we know that x squared equals 4. So if I take the square root of both sides, the square root of x squared and the square root of 4, I can see that x equals 2, but 2 isn't the only number that I can square to get 4. X could also equal negative 2. And so the way we describe that, when we solve the equation, we could put a plus or minus sign in front of the square root. So we could say x squared equals 4. That implies that x equals plus or minus 2. In a similar way, if y squared equals 7, we could say y equals plus or minus the square root of 7. The square root property can be used along with other equation solving techniques to solve more complicated equations. In this first example, I want to isolate the a squared part of the expression to solve for a. So first I can add 80 to both sides. That gives me 5a squared equals 80. And then I can divide both sides by 5 to get a squared equals 16. And then finally we can apply the square root property. If I take the square root of both sides, I see that a equals plus or minus the square root of 16. In other words, a equals plus or minus 4. We can solve this last example in a similar way. And what I'd like you to do is take a few moments, pause the video, and try to solve this using the square root property and see what you come up with. I'll talk about the solution in just a little bit. I hope you paused the video to try to find a solution to this last example. Let's take a look at what we can do. Since the square is on the outside of the parentheses, I first want to take the square root of both sides. So that gives me m plus 1, because the square root cancels out the square. M plus 1 equals plus or minus the square root of 5, because we need to include both a positive and a negative solution. And then to complete the problem, I want to subtract 1 from both sides. And so that gives me a solution for m, two solutions for m. M could either be negative 1 plus the square root of 5 or negative 1 minus the square root of 5. And so we could write them together with a plus or minus symbol, or we could write them separately. M equals negative 1 plus the square root of 5, and the second solution is m equals negative 1 minus the square root of 5. These two expressions, they represent numbers, and we can find their values on the calculator. If I add the square root of 5, negative 1 plus the square root of 5, the square root of 5 is a little bit bigger than 2 because 5 is a little bigger than 4. We end up with negative 1 plus something bigger than 2 is 1.236, and so on. And if I take negative 1 minus the square root of 5, we get negative 3.236. So those are the decimal approximations for these two solutions. I hope you enjoyed the video. Thanks for watching.